Welcome to this video tutorial on an overview of functions. We're going to look at two main types of problems here. First, algebraically finding the composition of functions, and secondly, working with domain, range, and composition from the perspective of a graph. So here's the first type of problem we're going to look at. We've got functions for f, g, and h. We're going to find the following compositions. Perhaps you want to hit pause and see if you can work them out before we discuss. In this first one, we want f of g of x, which means g is going to be on the inside. So what we're going to do is we're going to look for g. We're going to replace it with what g is actually equal to. In this case, that would be 5x minus 3. Once we have made that replacement, we're then putting 5x minus 3 into f, which means we're going to take the rule for f, and everywhere that we saw an x, we're going to put 5x minus 3. So then we're going to have minus 5. Now there was an x there, but we're going to turn it into 5x minus 3, and then we have a plus 4. Now be careful with foiling, because this means that we've got 5x minus 3 times 5x minus 3. And I will distribute here. This will be a minus 25x plus 15 plus 4. Foiling out the 5x minus 3 times 5x minus 3, we'll get 25x squared. Then we're going to have a minus 15x and another minus 15x, which will be a minus 30x. And a negative 3 times a negative 3 will be plus 9. Simplifying some of these items off on the side, 15 plus 4 is 19. Now we have to run through with the 2. So we'll get 50x squared minus 60x plus 18. But then we also have to combine everything at the very end. So we'll have 50x squareds minus 85x's plus 37. Please simplify as much as possible, and that would be completely simplified. That would be the answer to f of g of x. But now, what about g of f of x? So that's g parentheses f parentheses x. Please, you will need to show that step. Make sure you do. Now we're going to go over here and look at f of x. And we're going to replace f of x with what it's actually equal to, which is the 2x squared minus 5x plus 4. So now we're putting 2x squared minus 5x plus 4 into g. So everywhere we saw an x, we are going to replace it with 2x squared minus 5x plus 4. So g was 5 times x minus 3, but we're replacing x with what we have. Now we'll FOIL this out or distribute the 5, whichever way you want to look at it. And then we'll combine our like terms. So we'll get 10x squared minus 25x plus 17. That would be our final answer. But now using these same f, g, and h expressions, let's try our hand at these two items. Perhaps you want to hit pause and try them before we discuss. This is h of g of x. Then we're going to replace the g with 5x minus 3. And again, the reason that we're doing that is we know that g of x is equal to 5x minus 3. Now we're going over to h, and anywhere we see an x, we're replacing it with 5x minus 3. And I always think it's wise to wrap that in parentheses. We can debate if that's really needed, but I think it's helpful. So this will turn out to be the square root of 5x minus 10. Simplify as much as you can, but don't do more than you can do. With a subtraction or an addition inside the square root, there's no further simplification that's possible, at least that we're going to care about. Then over here, this is g of h of x, so g parentheses h parentheses x. H is square root of x minus 7. So again, we're just making the substitution based on knowing that h of x is equal to radical x minus 7. Now go to g. Anywhere we see x, we will replace it with the square root of x minus 7. And there's actually no simplification we can do here. I'm just going to rewrite it so that it's all the same color as we write it out. And there we go. That would be g of h of x. One more set of problems here. Perhaps you again want to hit pause before we continue. So over here on the left, this is f parentheses h parentheses x. We replace the h of x with what it's equal to, which is radical x minus 7. And again, one more time, that just comes about because we know h of x is equal to radical x minus 7. Then we go to f, and anywhere we see x, we replace it with radical x minus 7. Watch out because we've got some squares and other signs that we have to be careful with. I like to put parentheses around things when we make the substitution. Now when you square a square root, it cancels. So this is just going to become x minus 7. There's no further simplification we can do here, but this plus 4 is off on the side. So this will turn into 2x minus 14 minus 5 radical x minus 7 plus 4. We can combine the negative 14 and the 4, and I'll write this as 2x minus 10 minus 5 radical x minus 7. The exact order doesn't matter, so perhaps you wrote that as 2x minus 5 radical x minus 7 minus 10. The order doesn't matter, but we do need those items listed. For the last one, it's h parentheses f parentheses x. I need to see this next step where you show me that you're plugging in 2x squared minus 5x plus 4 in place of f of x, because that's what f is equal to. Now in h, anywhere we saw an x, we're going to replace it with 2x squared minus 5x plus 4. And then we'll have a minus 7 on the side. Simplify it, so this is 2x squared minus 5x minus 3. There's no further simplification that can reasonably be done to that expression, so that's where we would stop. Now again, that was the overview algebraically of function composition. Let's look at the graph. This is a problem similar to what we discussed in class. So a couple things to notice. This is this graph down here that I'm highlighting in blue based on its label. And g of x is this graph over here that I'm kind of tracing in magenta based on its label. So now when we go for domain, domain is the x values. The graph in blue goes to the left, 1, 2, 3, 4, 5. So its domain starts at negative 5. And since that point is actually on the graph, we put a rectangular parenthesis around it. The rectangular parenthesis means there is an x value of negative 5. And as we go to the right, there's points on the graph, points on the graph, points on the graph. So how far to the right does it go? Well, over to here, which is 1, 2, 3, 4, 5, 6, 7. Goes to the right 7. That point is actually on the graph as well with an x value of 7. So we put the rectangular parenthesis on it. Now range means how low does it go? It goes down 1, 2, 3, 4, 5, 6. That would be a negative 6. That point is actually on the graph, so we will put the rectangular parenthesis around the negative 6. And it goes up to this spot right here, which is at negative 2. Likewise, that's on the graph. Now for the graph of g of x, it goes to the left 1, 2, 3, 4, 5, 6, 7, so we'll put the negative 7, but be careful. It's missing a point that has an x value of negative 4. So it goes till negative 4 and then it stops for a second because x actually cannot equal negative 4. And then it picks up and it goes until 2, but then there's another open dot and there's a problem at 2. X can't actually equal 2. And then it continues to 3, 4, 5, 6, 7, so it goes till 7. That point's actually on the graph, so then we put the rectangular parentheses. Now for g, it goes down to 1, so the range starts at 1, and that's actually on the graph. We put the rectangle. As we scroll up, yes, this point is missing, but it has a y value right here that covers for it. And yes, this point is missing, but it has a y value over here that covers for it. So there aren't any problems from a y perspective. It goes all the way up to 1, 2, 3, 4, 5, 6. So we'll put the 6. Now, f of negative 3. What this means is we're going to go over to where the x value is negative 3. And when we go to where the x value is negative 3, we're going to see what is the y value on f. Well, that's right here. And the y value is down 2, so that's going to be a negative 2. The next one, it says what is the f value at 3? We go to where x is equal to 3, and we identify where the graph of f is. It's down 1, 2, 3, 4, so that's going to be a negative 4. G of negative 4. Well, we go left 1, 2, 3, 4. Ooh, there's not a point there. Be careful. That one does not exist. And we put DNE for does not exist. And at x equals 1, G is up 1, 2, 3, 4. So that's going to be a 4. Now the last things we're going to do is look at it numerically with a composition. We need to write this out as f of g of negative 2. Now what is g of negative 2 equal to? We'll go to negative 2, and g is up 1. So g of negative 2 is 1. And then where is f of 1? Well, when x equals 1, f is down 1, 2, 3, 4, 5. So that would be at negative 5. And that's the correct answer to that problem. Please show the work in the exact same way that I just showed it. So here, g of f of negative 1. We need to figure out where f is at x equals negative 1. It's down 1, 2, 3, 4, 5, 6. So f of negative 1 is a negative 6. Now g of negative 6. Go to the left 6. 1, 2, 3, 4, 5, 6. G is up 1, 2, 3, 4, 5. So that's going to be our answer to that whole expression. It's 5. Then f of g of 4. Okay, so g of 4. Go to our graph. Go right 1, 2, 3, 4. Where is g? Well, it's up 1, 2, 3, 4, 5. And now when we go to 5, for the x value, where's f? 1, 2, 3, 4, 5. F appears to be down 1, 2, 3. So the answer there would be negative 3. And our last example, g parentheses f parentheses negative 2. G of f of negative 2. F of negative 2, we go left 2. F is down 3, so that'll be a negative 3. And g of negative 3, so if we go left 3, g is up 2, and that's going to be a positive 2. So keep track of how the graph works. Please show your work as we described, and hopefully the ideas of functions, compositions, domains, and ranges makes sense.